1D, 2D and 3D boxes and degeneracies. So in this lecture we are going to discuss about all these three type of boxes, that is particle in a box ideas. So first we are going to discuss about 1D box, particle in 1D box. Okay, the 1D box idea is like a straight line is there. So a particle can oscillate in between these two boundaries, that is boundaries 0 to L. Okay, so this region is restricted for the particle and this region is also restricted for the particle because boundaries are having infinite potential. Okay, so particle can oscillate only in between these two boundaries and the potential of the particle is 0 because it is a free particle. So when oscillating the particle, there will be associated matter waves and it will form some stationary waves like this one. Okay, so there is a wave function psi and I told you the wave function for particle in a 1D box of length 0 to L, and this one is definitely you can see it is a asymmetric box. Why? Because about the x equal to 0 point, the box is asymmetric. Okay, the box is only on the right hand side. There is no box on the left hand side. That is why it is called asymmetric about x equal to 0. So this is an asymmetric case, and we got the wave function psi n is equal to root 2 by L sin n pi x by L, and we got energy En is equal to n square pi square h square by 2m L square. Here this one is represent the first wave function, ground state wave function psi 1, and suppose the length is same, okay, 0 to L, and if the stationary wave is like this one, okay, then this is corresponds to wave function psi 2. Here you can see the wavelength is different in these two cases, and you know the wavelength is associated with the frequency and frequency is associated with the energy. So if wavelength is changing, the energy of the particle also will change. That is why we get different energies for different wavelength. Okay, and in general this is psi n equal to root 2 by length of the box. Here it is L, that is why I substituted L. If the length of the box is 2L, then you have to substitute 2 by 2L. Okay, into sin n pi x by length. That is the length of the box, right? And the energy expression is n square pi square h square by 2m into length of the box into square. So the energy of a particle in a box is inversely proportional to length square, and it is dependent only on length of the box. Okay, and here what we are going to discuss is about the degeneracies. Here for 1D box, no degeneracy. No degeneracy for 1D box. So you will have a doubt, what is this degeneracy? Degeneracy means if there are two states, phi 1 and phi 2, and both of the state have same energy E, then we can say phi 1 and phi 2 are degenerate states. That is, two states having the same energy, then we can say they are degenerate state. And here the degeneracy is equal to 2. Why? Because here two states are there. Two states have same energy, therefore its degenerate is 2. If there are three states, psi 1, psi 2 and 3, and all these have same energy E, then we can say psi 1, psi 2, psi 3 are degenerate states, and their degeneracy is equal to 3 because For all these three states, same energy. Therefore, degeneracy is 3. So I think you got the idea about the degeneracy. And for 1D box, it is non-degenerate. Because you can see for each of the state, see here we can substitute psi 1. Okay, for psi 1 you will get a particular energy E1, and for another state psi 2 you will get another energy E2, and for another state you will get another energy E3. There is no overlapping of energies. Each of the state have particular energy. Okay, that is why I am telling for 1D box, states are non-degenerate. Now let us discuss 2D and 3D boxes. First of all, we have to find out the wave function for free particle in 2D box and 3D box and corresponding energies. Now let us discuss 2D box, that is two-dimensional box. That is, particle is trapped in a two-dimensional box. Suppose this is the case. Okay, a box is there and a free particle is trapped inside. So these regions are forbidden for the particle. So the particle can move only inside this box. Okay, so there is some possibilities of stationary waves, like it can move in this direction. Okay, and it can make a stationary wave in this direction, or it can move in this direction and make a stationary wave in this direction. Okay, so these are the two possibilities. That is, I am considering two axes. One is x-axis and other is y-axis. So this is x-axis and this is y-axis, and this is origin. Okay, and the length of the box in the x direction I am restricted to Lx, and in the y direction the length of the box is specified as Ly. And this particle is a free particle. That means potential is equal to 0. So the particle potential is 0. And for this corresponding wave, stationary wave in the x direction, there will be an energy Ex, and corresponding to a stationary wave in the y direction, there will be an energy Ey. That is, energies are Ex and Ey. Now, first of all, we have to find out these wave functions. What is this wave function? What is this wave function in the x direction and the y direction? So, how we can find out the wave function? We have to solve Schrodinger equation. What is Schrodinger equation? That is del square psi of xy. Here, wave function is a combination of x and y plus 2m e minus v by h cross square psi is equal to 0, where the psi is also a combination of x and y. Here, I told you this is a free particle, so v should be equal to 0. Here we are just following the same procedure we used to find out the wave function and energy of 1D box. Okay, if you have any doubt, just refer how we solve for 1D box. Okay, so we can substitute in this Schrodinger equation, that is del square. It is in 2D case, that will be dou square by dou x square plus dou square by dou y square. That is dou square by dou x square plus dou square by dou y square into psi of xy plus 2m by h cross square into e. So v is equal to 0 into psi of xy is equal to 0. Here, to solve this equation and making the solution simpler, I am doing one mathematical manipulation. That is, I am going to represent this psi of xy. Here, psi of xy means the wave function is a combination of x and y. Now, I am going to separate into two components. That one component contains only x coordinate and other component contains only y coordinate. So, I am separating the variable into two functions. Now, I am going to substitute this function in the position of psi of xy. That is dou square by dou x square plus dou square by dou y square into xy plus 2m by h cross square e into xy is equal to 0. Now we can perform this partial derivative on this xy that we know when we are doing this one. I tell you one example, that is dou square by dou x square on x of x into y of y. That is equal to, first you have to operate this dou square by dou x square on first term, that is dou square by dou x square of x into y of y, plus now we have to operate this dou square by dou x square on this term, that is dou square y of y by dou x square into x of x. See, this function is a function of only y. So if you are taking derivative with respect to x, it will be equal to 0. Okay, so when we are performing this derivative, we will get this function only. Okay, so what we will obtain here, that is when we are operating dou square by dou x square on xy, we will get y outside, and dou square x by dou x square, plus now we have to operate this term, that is we can take x outside, and dou square y by dou y square plus 2m e xy by h cross square is equal to 0. Now I am going to do again some mathematical manipulation, that is I want to remove this xy. So I am going to divide this entire term by xy. So what we will get here, y by xy, so yy will cancel and remaining only 1 by x into dou square x by dou x square, plus when we are dividing this x by xy, x will cancel, only y will remain, that is 1 by y dou square y by dou y square plus 2m e by h cross square equal to 0. Here I told you there is two energies. One energy is in the direction of x and another energy in the direction of y. So the total energy is sum of these two. So I can separate this term. So this term is corresponds to x component. So and this component is correspond to x component. Okay, and this is corresponds to y component, and this energy is correspond to y component. So I am going to separate this equation into two. That is 1 by x dou square x by dou x square plus 2m ex by h cross square plus 1 by y dou square y by dou y square plus 2m ey by h cross square is equal to 0. So this is equal to 0 means individually this term should be equal to 0 and this term also should be equal to 0. That is, we can write 1 by x dou square x by dou x square plus 2m ex by h cross square is equal to 0, and 1 by y dou square y by dou y square plus 2m ey by h cross square is equal to 0. Now again I want to remove this 1 by x and here this 1 by y. So I am multiplying this term with the x. So I will get dou square x by dou x square plus 2m ex x by h cross square equal to 0, and here I am going to multiply this term by y. So I will get dou square y by dou y square plus 2m ey y by h cross square equal to 0. Now I am going to substitute kx square for this term because this is ex, that is why I am substituting kx square, and for this term this is function of ey, so I am substituting ky square. Now it is like a d square plus kx square equal to 0. and this one d square plus k y square is equal to 0. This is a differential equation, and I told you how to solve such kind of differential equation. So we get a solution here, and here also we get a solution, and then we have to substitute boundary conditions. Now what is the boundary conditions here? Here the particle is trapped in a box, right? So this is x-axis and this is y-axis. Okay, and I told you if the particle is trapped and it is forbidden from any other region. Okay, so there will not be any wave function corresponds to this particle out in this region. See, in this region. Okay, this is the region where particle is forbidden. Okay, so the particle will be bounded only inside the box. That means in the x direction the length is 0 to Lx, and in the y direction 0 to Ly. Okay, so in this case we have to substitute this condition, that is wave function psi is equal to 0 for x equal to 0 and x equal to Lx. Okay, and for this case we have to substitute psi is equal to 0 for y is equal to 0 and y is equal to Ly. Okay, so by substituting these boundary conditions and after some mathematical manipulations, we will get the final result. Actually, we've done all those things for the 1D case. So if you want to do by yourself, just refer the 1D box. Okay, so by substituting all the boundary conditions, finally you will get the answer, that is x equal to root 2 by Lx sin nx by x by Lx, and y is equal to root 2 by Ly sin ny pi y by Ly. And earlier we defined the wave function psi of xy is equal to x of x into y of y. Okay, so in order to find out the final wave function xy for 2D box, we have to multiply these two times, that is root 2 by Lx into root 2 by Ly sin nx pi x by Lx into sin ny pi y by Ly. So we got the wave function corresponds to particle in a 2D box, and we can find out the energy for the particle in the x direction and y direction. That is, for x direction we will obtain Ex equal to nx square pi square h square by 2m Lx square, and for y direction we will get Ey is equal to ny square pi square h square by 2m Ly square. And earlier we defined the energy E is equal to Ex plus Ey. That is the total energy of particle in 2D box. That is, we will get E equal to nx square by Lx square plus ny square by Ly square into pi square h square by 2m. So these are the wave function, and the energy of a 2D box, particle in a 2D box. Okay. Now we have to discuss about degeneracy of particle in a 2D box. The first question is, why degeneracy is arising? It is due to the symmetry. Reason for degeneracy is symmetry. Okay, I will tell you the explanation. Let us consider the 2D wave function, that is equal to root 2 by Lx root 2 by Ly sin nx pi x by Lx into sine ny pi y by Ly. And we got the energy expression, that is E is equal to nx square by Lx square plus ny square by Ly square into pi square h square by. Now I am considering a symmetry case, that is Lx is equal to Ly is equal to L. Okay, this is the condition of symmetry. Then what will happen? The wave function, 2D wave function, is equal to root 2 by Lx and Ly are same. So it will be 2 by L sine nx pi x by L into sine ny pi y by L. And the corresponding energy E become nx square plus ny square into pi square h square by 2ml square. Here this nx value is equal to 1, 2, 3, etc. and ny is equal to also 1, 2, 3, etc. Now let us discuss how this degeneracy arises and what is the degeneracy for each of these states. Now I am going to make a table. In this table, the first term is nx plus ny, second is nx comma ny, next is nx square plus ny square, and then is increasing order. Next one is energy E is equal to nx square plus ny square into E, where E is the state. Okay. Then wave function psi of xy, and last one is degeneracy. Okay, first I am taking the combination of nx and ny. So first combination I am taking 1, 1. So nx is 1 and ny is 1, that is nx plus ny is equal to 2. So nx is 1, ny is equal to, ny is also equal to 1. So nx square plus ny square, that is 2. And the next one is, okay, I'll leave it is 2. And E is equal to nx square plus ny square into E, that is 2E. And here the wave function psi of xy. So what is the x value? For nx, this is 1, ny, this is 1, that is psi 1, 1. Okay, here I tell you the degeneracy last. The second one. Now we have to take nx plus ny is equal to 3. So we can take nx equal to 1 and ny equal to 2. So we will get nx plus ny is equal to 3. There is another combination, that is we can take nx equal to 2 and ny is equal to 1. Okay, so now we can find out nx square plus ny square. Here for this both combination, this value is same, that is 5. Okay, now just leave this 5 here because now it is not needed. Okay, now we have to find out the energy, that is energy will be equal to 5E. Here you see there are two combinations, that is wave function psi 1, 2 and psi 2, 1 have the same energy, that is 5E. That is there are two states having the same energy, therefore degeneracy is 2. Here the state have only one energy, that is degeneracy is 1. Okay, now we can take the other combination, that is 4. So how we can make 4? We can take 2 and 2, that is nx is 2, ny is 2. Another combination is nx equal to 1, ny is equal to 3, or nx equal to 3 and ny is equal to 1. Now we can calculate nx square plus ny square for the first state. That is 2 square plus 2 square. That is 4 plus 4, 8. And for this 2 case, what is the energy? 1 square plus 3 square, that is 10. So the increasing order for this 4, it is 8, 10. If I am write this 1, 3 first, okay, 1, 3 combination and 3, 1 combination first, then I have to interchange this increasing order. Here I wrote in the correct format, so no need to interchange. Okay, so we got this energy corresponds to this one is 8E, and the corresponding wave function is psi 2 2. Okay, this 80 energy is only for one state, psi 2 2, so the degeneracy is 1. Now for these states, the energy is 10E. But see, for this both the state, it have same energy, that is state psi 1 3 and psi 3 1 have same energy. That means it is a degenerate state and its degeneracy is 2, because two states have same energy. Okay, that is degeneracy is 2. Similarly, you can calculate for 5, that is how we can make 5 from combination of nx and ny. That you have to take 1, 4, or you can take other combination 4, 1, or other combination 2, 3, and the other combination is nx is equal to 3 and ny is equal to 2. Is there any other combination is possible? No. Okay. Now we have to find nx square plus ny square. For this 2 combination, what is the value? It is 1 square plus 4 square, that is 70. Okay. Now let us take the other combination, that is 2 and 3. So if you are finding nx square plus ny square, that is 2 square 4 plus 9, that is 13. Now we have to write this in the increasing order, because for this combination of nx plus ny, we got two values 17 and 13, and here I am writing it in the increasing order, that is 13 and 17. Okay. So for one of the states, we will get 13E, and other state we will get a 17E. And for which state we will get 13E? That is psi, this 2, right? Psi 2 3 and the psi 3 2. And for which state we will get 17E? For this state, that is psi 1 4 and psi 4 1. Okay, here you can see there are two states corresponding to same energy, that is 13E, that is this degeneracy of state is 2. And here also two states having same energy, that is degeneracy is 2. So for a 2D box, particle in a 2D box, the order of degeneracy is, for the ground state it will be 1, for the first excited state it will be 2, then it will be 1, then 2, 2, 2. This is a very important thing, please remember. For the 2D box, the ground state is non-degenerate, first excited state is doubly degenerate, and second excited state is non-degenerate, and the third excited state is doubly degenerate, and so on. Okay, so please remember, because in solving some problem we need to know the degeneracy, mainly in perturbation problems. So the order of degeneracy for a 1D box is 1 2 1 2 2 2, 1 2 1 2 2 2. Okay, please remember. Now we are going to discuss about 3D box and the degeneracies. We already solved the Schrodinger equation for 2D box. So in the same fashion, you can solve for 3D box also. So in 3D box, the wave function is a combination of x, y, z. So we can write it as a combination of psi of x, y of y, and the z of z. Then we can substitute in the Schrodinger equation, and this is for a free particle, and this one is also for a free particle. So we can substitute v equal to 0 in the Schrodinger equation, and the energy E will be equal to Ex plus Ey plus Ez. Okay, so substitute all this parameter in the Schrodinger equation and solve the boundary conditions. So finally, you will get wave function psi is equal to, similar to 2D box, that is 2 by Lx root 2 by Ly root 2 by Lz sin nx pi x by Lx into sin ny pi y by Ly into sin nz pi z by Lz. And you will obtain the expression for energy E as nx square by Lx square plus ny square by Ly square plus nz square by Lz square into pi square h square by 2m. So this is the expression for wave function and the energy of a 3D box. Very important. Okay. Now our interest is about its degeneracy. So I told you degeneracy arises from symmetry. So I am considering the symmetry case, that is Lx equal to Ly is equal to Lz equal to L. That is now the particle is in a cube. Okay. So in a cube, what will be the energy and the wave function? That is what we are going to find out. So here this expression for energy will reduce us to nx square plus ny square plus nz square into pi square h square by 2m, where nx can have values 1, 2, 3 etc. combination, and ny can have the combination 1, 2, 3 etc. nz also can have the combination 1, 2, 3 etc. Here also, for simplicity, I am calling this term as E. That is, E is equal to pi square h square by 2m. So as we done for 2D box, we can take the combination, that is nx plus ny plus nz, and the combination nx comma ny comma nz, and nx square plus ny square plus nz square. Then the increasing order of energy, then its energy E, that is equal to nx square plus ny square plus nz square into E, where E is pi square h square by 2m. Then wave function psi of x comma y comma z, and the last degeneracy. So the first combination, that is the minimum value of nx is 1 and ny is 1 and nz is 1. So 1 plus 1 plus 1, so the minimum value is 3. That is nx is 1, ny is 1 and the nz is 1. So when we are taking nx square plus ny square plus nz square, we will get 3. So just leave it as 3, and so we will get the corresponding energy as 3e, and the wave function is x value is 1, y value is 1, z value is 1, right? That is psi 1, 1, 1. So it is not degenerate. For this wave function, there is only one energy, that is 3. So degeneracy is 1. That is, it is not a degenerate state. Now we can take the other combination, that is 4. 4 means we can take nx as 1, ny as 1 and nz as 2. Or we can take nx as 1, ny as 2 and nz as 1. Or we can take nx as 2, ny as 1 and nz as 1. So when we are adding, you will get the 4. So for all this state, nx square plus ny square plus nz square is equal to 4 plus 1 plus 1, that is 6. That is order is 6, and here the energy is 3e, and the wave functions are psi 1, 1, 2, psi 1, 2, 1, and the psi 2, 1, 1. So here for all these states the energy is same, that is 6e. So these are degenerate by 3. Okay. Now we can consider the other combination, that is 5. The increasing order is 5, 3, 4, 5. Okay. 5, how we can make 5 from this combination of nx and ny and nz? The first one is 1, 2, 2. Okay. Here it is nx equal to 1, ny is equal to 2, and nz is equal to 2. Now we can take nx as 2 and ny as 1 and nz also as 2. And other combination is also possible, that is 2, 2, 1. Okay, so for all these states, nx square plus ny square plus nz square is 9. And for this 5, there is other combination is also possible, that is 3, 1, 1. Okay, and 1, 3, 1, and 1, 1, 3. Okay, that is also equal to 5. So for this combination we will get a value, that is 9 plus 1 plus 1, that is 11. Okay, so here it is increasing order is 9 and 11, and the energy E is equal to 9e, this is 11e, and the corresponding wave functions are psi 1, 2, 2, psi 1, 2, 1, and psi 2, 2, 1. All these three states have same energy 9e, so the degeneracy is 3. And for this 11e also, the wave functions are 3, 1, 1, psi 1, 3, 1, and psi 1, 1, 3. All the three states have same energy, so the degeneracy is 3. Now the next one is 6. For 6, we can take a combination of nx equal to 1, ny is equal to 2, and nz is equal to 3. And other combinations are 1, 3, 2, and 2, 1, 3, 2, 3, 1, and the other combination is 3, 1, 2, 3, 2, 1. So there are total 6 combination, and all these 6 combination, the value nx square plus ny square plus nz square is same, that is 14. Not only this, we can make 6 by combination of 2, 2, 2. Okay, and there is the possibility of making 6 by combining 1, 1, and 4. So here we will get other combination, that is 1, 4, 1, and 4, 1, 1. Okay, and here it is 2 square plus 2 square plus 2 square, that is 12, and for this combination it will be 1 square plus 1 square plus 4 square, that is 18. So the increasing order, that is 12, 14, and 18. So the energy, that is 12e, 14e, and 18e. And the corresponding wave functions are, here it is psi 1, 2, 3, psi 1, 3, 2, and psi 2, 1, 3, and psi 2, 3, 1, psi 3, 1, 2, psi 3, 2, 1. All these 6 states have same energy 12e, so the degeneracy is 6. And here it is 14e, that is corresponding wave function is 2, 2, 2, and the degeneracy is 1. That is, it is not degenerate. And here it is 3 combinations have same energy 18e, that is 1, 1, 4, and psi 1, 4, 1, psi 4, 1, 1. So there are 3 states. Okay, so this is the degeneracies of various states. That is, for a 3D box, the degeneracy You can check this column. Okay, so in this column what you got is 1 3 3 3 1 6. You can just check, we got the degeneracy in this order. That is, the ground state is non-degenerate. First excited state is degenerate by 3, and the second excited state is also degenerate by 3, and so on. So this is the order of degeneracy. Please remember these values because this is very important. We need this information to solve some problems. So these are very important. So remember the degeneracy of particle in 2D box and the degeneracy of particle in 3D box and their wave functions and their energies. Here we can summarize all these ideas. That is, first I am considering this 2D box. For 2D box, the wave function xy is equal to root 2 by Lx into root 2 by Ly into sine nx pi x by Lx and the sine ny pi y by Ly, and the energy E equal to nx square by Lx square plus ny square by Ly square into pi square h square by m to m. And for 3D case and the degeneracy is 1 2 1 2 2 2. Okay, this is the order. And for 3D box, the wave function psi xy z is equal to root 2 by Lx root 2 by Ly root 2 by Lz sine nx pi x by Lx into sine ny pi y by Ly and the sine nz pi z by Lz, and energy is equal to nx square by Lx square plus ny square by Ly square plus nz square by Lz square into pi square h square by 2m. And the degeneracy is 1 3 3 3 1 6, and the coming of order is like this: 3 3 3 6. Okay, so order is 1 3 3 3 1 6 3 3 3 6. Okay, remember this fashion. Okay, first 1 3 3 3 1 6 3 3 3 6. Okay, please remember this degeneracy. That is, ground state is non-degenerate. Okay, first excited state is degenerate by 3, second excited state is degenerate by 3, and so on. These are very important, please remember. An example problem. Find the degeneracies of states in the order ground state, first excited state, second excited state, and so on. If there is a degeneracy, there will be some symmetry condition. So the given symmetry condition is Lx is equal to Ly by 2. So this is the symmetry condition. Lx is half of Ly. So if you are constructing a box, 2D box, where this is Ly value, okay, and this is Lx value. So roughly this Lx value is half of Ly value. Okay, if such a box is there, then there will be different states. Okay, so the question is to find out the degeneracies. Maybe some of the states have same energy. That is what they are asking to find out. Okay, so this is the condition, and we know the general expression for energy in 2D box. What is it? That is E equal to nx square by Lx square plus ny square by Ly square into pi square hz square by 2m. Now we have to substitute this symmetry condition. That is, here I am going to consider Ly is equal to L. Therefore, I can write Lx equal to L by 2. So I am going to substitute Ly is equal to L and Lx equal to L by 2 in this equation. That is, we get energy E equal to nx square by Lx square, that is Lx is L by 2 all square plus ny square by Ly square. Ly is equal to L, that is L square into pi square hz square by 2m. That is equal to E is equal to, see, we get nx square into 2 square, that is 4nx square by L square plus ny square by L square into pi square hz square by 2m. Here this L are common term, so we can take it outside. That is, we get E is equal to 4nx square plus ny square into pi square hz square by 2m L square. Here also I am considering this term as E, or representing this term as E. That is, the energy is equal to 4nx square plus ny square into E. Now the question is to find out the degeneracies. How we solve for degeneracy problem in the earlier case? We consider nx and plus ny. Okay, then we took the combination nx and ny. Then we took nx square plus ny square. Then we took its increasing order. Then we found out the energy, that is nx square plus ny square into E, and then we found the wave function. Then we found the degeneracy. This is what we done in the earlier case. Here there is a slight modification. Here what is the equation for mg? That is 4nx square plus ny square. Therefore there will be an additional term, that is 4nx square. Here also there will be an additional term, that is 4nx square plus ny square into E. Okay, so I told you the various value nx can possible is 1, 2, 3, and various value possible to ny are 1, 2, 3, etc. So first we have to take the lowest combination, that is 1 and 1. So nx is 1, ny is 1, so we will get nx plus ny equal to 2. That is, nx is 1, ny is 1. Now we have to substitute this value in this equation, that is 4nx square plus ny square, that is 4 plus 1, that is 5. And the next combination, that is 3. How we can make 3? We can take 1 and 2, or we can take nx as 2, ny as 1. So for this case, when nx equal to 1, 4nx square, that is 4 plus 2 square, that is 4 plus 4, 8. And now we are considering this case. Now nx is 2, so 2 square is 4, 4 into 4 is 16 plus ny square, that is 17. Now we can consider the other case, that is 4. How we can make 4? We can take combination of 1, 3 and 3, 1, and we can take a combination of 2, 2, right? So when we are substituting nx equal to 1 in this equation, we will get 4 plus 3 square, that is 4 plus 9, that is 13. Next combination is 3 and 1, that is 3 square into 4, that is 9 into 4, that is 36, plus 1, that is 37. And 2, nx is equal to 2, so 4 into nx square, that is 4 into 4, 16 plus 4, that is 20. Now we can write this in the increasing order. So the first one is 5, second is 8, then 13, then 17, then 20, right? Now next time is not 37, because if you are considering this 5 combination, that is nx plus ny is equal to 5, you will get a combination 1, 4 and 4, 1, and other combination is 2, 3. So 1, 4, if nx is equal to 1, that is 4 plus 4 square, right? That is, again you will get a 20 value here. And 4 and 1, if you are substituting nx equal to 4, that is 4 into 4 square, that is 4 into 16 plus 1 square. Okay, leave, that is big value, right? Now we can consider the other term, that is 2 and 3. That is, when we are substituting 2 for this nx, it will be 4 into 4, that is 16, plus 3 square, that is 25, right? Similarly, you will get value for this one, and you can take other combination, that is 3, 2, okay, and so on. So I am going to write this in the increasing order, that is 20, and the next one is 25, and so on. Okay, if you solve for this 5 and other 6, then you will get more terms, then you can write it in the increasing order. Now I am stopping by 25. Okay, so the corresponding energies are 5e, 8e, 13e, 17e, 20e, and the 25e. So for energy 5e, the state is this one, that is 1, 1. For the energy 8e, the state is 1, 2, psi 1, 2. And for the energy 13e, the state is psi 2, 1. And the energy 17e, the state is psi 1, 3. Okay, next is 20e. For 20e, see, this one is corresponds to 20e, and this one is also corresponds to 20e. That is state psi 2, 2, and psi 1, 4 are corresponds to the energy 20e. And next one is 25. 25 is this one, right? 25 is corresponds to state psi 2, 3. Okay, so the degeneracy is 1, right? Here also 1, here 1, here 1. But for 20e, there is 2 states having same energy, that is degeneracy is 2, and for this one degeneracy is 1, and so on. Okay, so the order of degeneracy is ground state 1, first excited state 1, second excited state 1, and so on. Okay, that is, this is the order, that is 1, 1, 1, 1, 2, 1, etc. Let us consider one more example problem. So for degeneracies, there will be a symmetry. And here in this case, the symmetry condition is Ly is equal to Lx by 2. That means if Lx equal to L, then Ly is equal to L by 2. That is, the corresponding energy E will be equal to, we know the general expression is nx square by Lx square plus ny square by Ly square. It is a 2D case. If it is a 3D case, then there will be nz square by L z square time also. But this is a 2D, so we can cross by these two times into pi square h square by 2m. Okay, now we have to substitute this Lx value and Ly value. So we will get the energy of this particular case, symmetric case, that is E equal to nx square by Lx is L, that is L square, plus ny square by Ly, Ly is L by 2. Okay, so L by 2 all square into pi square h square by 2m. So we can rewrite this as E is equal to nx square plus ny square, and here this is L by 2, so L by 2 all square, so there will be a 4 time. Okay, and I am taking this L square time as a common time, that is into pi square h square by 2m L square. Okay, and I am calling this entire term as E. So we got the energy equation, that is energy E is equal to nx square plus 4ny square into E. Now the question is to find out the degeneracies of ground state, first excited state, second excited state, and so on. Okay, so we will follow a very systematic method here to understand the concept. After understanding the concept, you can do it in a very shortcut ways. Okay, so the systematic way is here, the nx value can have 1, 2, 3, etc. and ny value also can have 1, 2, 3, etc. So there is different combination of nx and ny's are possible. So we are going to consider those combination. That is why I am taking nx plus ny. And I am taking this combination nx, ny to represent the corresponding wave function. And I am writing this energy expression, that is nx square plus 4ny square. Then I am going to write this in a increasing order of energy. That is what we want to find out. That is, first we want to find out the degeneracy of ground state, then first excited state, then second excited state. That is why I am rewriting the values in the increasing order. Then the energy, that is energy will be nx square plus 4ny square into E. Then the corresponding wave functions, that is xy combination, then the degeneracy. Okay, so let us take the combinations. So nx, the minimum value of nx is 1 and minimum value of ny is 1. So nx plus ny, the first combination is 2. Okay, that is nx is 1 and ny is 1. And we can find out this nx square plus 4ny square, that will be equal to 1 plus 4, that is 5. Then we can consider the other combination, that is combination 3. So how we can make 3 from combination of nx and ny? We can take 1 and 2 or 2 and 1. Okay, so for 1 and 2, we will get 1 square plus 4 into 2 square, that is 4 into 4 plus 1, that is 17. And the second combination, that is 2 and 1, that is 2 square is 4, 4 plus 4 into 1, that is 8. Okay, so in the similar fashion we can find out the other combination also. The next combination is 4, that is nx plus ny is equal to 4. So how we can make nx plus ny 4? One possibility is 2, 2, and other combination is 1, 3, and other is 3, 1. So when we are taking 2 and 2, nx is 2, ny is 2, what we will get? This will be 2 square plus 4 2 square, that is 4 plus 4 into 4, that is 16 plus 4, that is 20, right? Then other combination 1 and 3, that is nx square is 1 square plus 4 into 3 square, that is 4 into 9, that is 36 plus 1, that is 37. Next one 1 and 3, so 1 square is 9 plus 4, that is 13. And similarly we can find out the other combinations also, that is for 5, how we can make 5, that is 1 is nx is 1, ny is 4. Other combination is nx is 4, ny is 1. And the other combination is 2 3 and 3 2. Is there any other possible combinations there? No. Okay, so similarly you can find out the nx square plus 4 ny square value, okay, for all these terms. Then what you have to do? Then we have to write these terms in the increasing order. That is, here the first term is 5, then it is 8, right? Then what is the next term? Next term is 13. Next term is 17. And next term is 20 and etc. And the next term is not 37, because if you find out the combination of 5, then you will get some other values 25 and something. Okay, so next time will be that one. So you have to evaluate these terms and write it here in the increasing order. So the corresponding energy, that is E is equal to 5E. Here it is 8E, 13E and 17E and 20E. So the ground state energy is this one. First excited state energy is 8E. Second excited state energy is 13E, so on. Okay, so now we have to find out the corresponding wave functions. So 5 is corresponds to 1 1, right? That is psi 1 1. Next is 8. 8 is corresponds to this combination 2 1. Okay, the wave function corresponds to 80 will be psi 2 1. Okay, and next one, that is 13. 13 is here. The corresponding nx ny combination is 3 1. So the corresponding wave function will be psi 3 1. Next is 17. Okay, for 17 this is the combination, that is wave function will be psi 1 2. And next is 20e. 20e is this one, right? 20e, that is corresponds to 2 2. So the corresponding wave function is psi 2 2. And here if you consider the nx square plus 4 ny square value for this combination, 4 1 combination, again you will get a value 20, right? That is 4 square plus 4, okay, is 20. So for the case of 20, there is another wave function, that is this one. Okay, so for 20e, it is corresponds to another wave function also, that is 5 4 1. Okay, so there is two combinations. Here this 5e is corresponds to only one wave function, so the degeneracy is 1. Okay, here 8 is corresponds to only one state, so its degeneracy is 1. That is, it is not degenerate. Okay, and here also degeneracy is 1, here also the degeneracy is 1, and here see there are two states will have same energy, but the states are different. Psi 2 1, another is psi 4 1. States are different, but their energies are same. Okay, and there are two such states, therefore we call the degeneracies 2. Okay, so similarly you can find out the other terms also, that is for ground state it is non-degenerate, first excited state is non-degenerate, second excited state is non-degenerate, and the third excited state is also non-degenerate, but fourth excited state is degenerate by 2. So if you are writing the states, ground state, first excited state, second excited state, third excited state, fourth excited state, in an order, then the degeneracy is 1, 1, 1, 1, 2. And if you find out fifth excited state, you will get the degeneracy. So please find out the other terms also. So this is the degeneracy of various states for a box whose length Ly is equal to Lx by 2. Degeneracy from energy. In some question, an energy will be given and they are asked to find out degeneracy. That is, number of states having the same energy level. So let us consider one example problem. That is, energy is given, that is E equal to 32 pi square h cut square by 2 m l square. And specified, this is a 2D box. And find out the degeneracy. We know for a 2D box, the expression for energy is equal to nx square plus ny square into pi square h cut square by 2 m l square. Here this nx can have values 1, 2, 3, etc. and ny also can have values 1, 2, 3, etc. So now we can compare these two equations. So when we are comparing, we can find out 32 is equal to nx square plus ny square. That is, nx square plus ny square is equal to, should be equal to 32. So we have to find out what are the combinations of nx and ny which will give this value 32. Okay, so that is what we are going to find out. So first I am taking nx equal to 1. That is 1 square plus ny square should be equal to 32. Okay, so 1 square is already taken, that is 1 is already taken, therefore the remaining is 31. Okay, so is any combination of ny square will give 31? No, because the ny values are 1, 2, 3, etc. That is, its square will be 1, 4, 9, it is 4, 5, that is 16, 25 only. Okay, so this is not a perfect square. So any value of ny will not give 31. So this is not possible. Now what is the next combination? Now I am taking nx equal to 2. That is 2 square plus the remaining term. So here already 4 is gone. So the remaining term is 28 should be equal to 32. Here also we can write 28 as a perfect square. So this combination is also not possible. Now I am going to take nx as 3. That is 3 square plus the remaining is 23 is equal to 32. 23 is also not a perfect square. So this is also not possible. Next is 4 square. So the remaining is 16. That is equal to 32. So 16 can be written as 4 square, right? Therefore nx equal to 4 and ny equal to 4 give this energy is equal to 32 pi square h cut square by 2 m l square. So there is one wave function, that is psi44, which give this energy. Now we can check is there any other combination of nx and ny will give the same energy. Now we take 5 square, nx is 5, so it is 25, the remaining is 7. Okay, that is equal to 32. Again, this 7 is not a perfect square, so this is not possible. So only possible combination is nx equal to 4 and ny is equal to 4, and that corresponds to the energy 32 pi square h square by 2 ml square. So there is only one state having this energy, therefore degeneracy is equal to 1. Next problem is also a 2D problem. Here also a box has a symmetry, that is Lx equal to Ly is equal to L, and the energy is given, that is equal to 10 pi square h square by m L square. Here we know for a 2D box, the energy expression is equal to nx plus ny square into pi square h square by 2 m L square. Here what I am going to do first is I am multiplying this term with 2 and dividing with 2. So see, this term is common. Okay, here and here this term is same. So the remaining term, that is nx square plus ny square is equal to 2 into 10, that is 20. Now we can consider the different combination of nx, that is 1, 2, 3, and ny 1, 2, 3, etc. So first I am considering, this is the procedure. First you take the lowest value of nx, that is 1 square, plus here what we want to get? We want to get 20. So the remaining term is 19, right? And you check, is it possible to write this term as a perfect square? If it is not possible, then nope. Okay, that is, this combination never exists. That is, here nx is 1 and any other combination of ny will not give 20. Okay, next we can take nx value 2, that is 2 square, that is 4 plus 16 will give 20. 16 is a perfect square, that is 4 square. Okay, that is nx equal to 2 and ny is equal to 2, then you will get a value corresponds to 20. Now let us check other combinations also. That is 3 square. 3 square plus remaining term is 11. We can write 11 as a perfect square. Okay, so this combination is not possible. Next we can take nx equal to 4 square, that is 4 square we know 16 plus 4 is equal to 20. Here this time we can write as 2 square, that is the combination is nx equal to 4 and ny equal to 2. Sorry, here I made a mistake, that is this ny value is 4, right? Okay, then only we will get 60. Okay, that means this states, that is psi 2 4 and the psi 4 2 have the same energy 20 into pi square h square by 2 ml square. So there are two states having same energy, that means their degeneracy is equal to 2. Now let us consider a 3D case. 3D box with the Lx equal to Ly is equal to Lz equal to L. So there is a symmetry, so there will be a chance of degeneracy. Okay, and in the problem the energy is given, that is E is equal to 21 pi square h square by 2 m L square. So we know for a 3D box the energy expression is nx square plus ny square plus nz square into pi square h square by 2 m L square. That means nx square plus ny square plus nz square is equal to 21. And this nx can have values 1, 2, 3, etc. ny can have values 1, 2, 3, etc. nz also can have values 1, 2, 3, etc. So first we consider nx value equal to 1. That is 1 square plus, and I am considering ny value is also 1. Okay, that is 1 square plus is equal to 21. So the remaining term is 19. And we cannot write 19 as a perfect square. So this combination is not possible. that is combination of nx equal to 1, ny equal to 1 and any other combination of nz will not give this value 21. Okay, now we can check nx equal to 1 and ny equal to 2, that is 1 square plus ny value is 2 square, that is now is 5 is there, so it is equal to 21, so the remaining term should be 16, right? And here we can write 16 as 4 square. Okay, that means if nx equal to 1, ny is equal to 2 and nz is equal to 4, then we will get the energy 21. And we have to check other combination, that is I am taking 1 square plus I am taking 3, that is 3 square plus that should be equal to, the total value should be equal to 21. So 9 plus 1, 10. So the remaining term is 11. 11 we can write as a perfect square. Okay, so this combination is also not possible. Here you can take other combinations also, combinations of 2, nx equal to 2, nx equal to 3 and nz 1, 2, 3 values. But this is the only possible combination you will get energy equal to 21. And this is corresponds to a state, that is psi 1 to 4 and its energy is 21 pi square h square by 2 ml square. This question is about a particle trapped inside a cubic box. Okay. So cube has all the side will be same, that is here Lx equal to Ly equal to Lz is equal to A, that is cube of side A. And the potential inside the box is 0 and outside it is infinite. And the question is, if the particle is in an eigenstate of energy, E is equal to 14 pi square h square by 2 ma square, then its wave function is. For a 3D box, we know the wave function is, general wave function is psi xyz is equal to root 2 by Lx into root 2 by Ly into root 2 by Lz into sin nx pi x by Lx into sin ny pi y by Ly into sin nz pi z by Lz, right? And we know the energy also, that is energy will be equal to nx square by Lx square plus ny square by Ly square plus nz square by Lz square into pi square h square by 2m. But here in this case, you know, Lx equal to Ly is equal to Lz is equal to A, because it is a cubic box. So this wave function and energy will be xyz is equal to, here we can substitute this A for Lx, Ly and Lz. So we will get 2 by A all raised to 3 by 2 into sin nx pi x by A into sin ny pi y by A into sin nz pi z by A. And the energy expression become E is equal to, here also Lx equal to A, Ly is equal to A and Lz is equal to A. So I am taking these terms as a common term. So I will get nx square plus ny square plus nz square into pi square h square by 2 ma square. So this is the wave function and its corresponding energy for the given problem. And here in this question, this energy is given, that is equal to 14 pi square h square by 2 ma square. That is, this term is common term, right? So that means nx square plus ny square plus nz square is equal to 14. Here we know these values. Nx can have values 1, 2, 3, etc. And ny also can have values 1, 2, 3, etc. Nz is also can have values 1, 2, 3, etc. Okay, so we have to find out which combination of nx, ny and nz will give this value 14. Okay, let us consider nx as 1. Okay, so that is 1 square plus ny also I am considering as 1, that is 1 square plus the nz square will be equal to 40. Okay, so here this 1, 1. So the remaining time is 12, right? So we cannot write 12 as a perfect square. It is not a perfect square. So this combination is not possible. That is, any combination of nz will not give this value 12. So this is not possible. Now what is the next combination? I am taking nx as 1 plus I am taking ny as 2, that is 2 square plus equal to 14. So I am choosing the nz value. So what should be the nz value? Here it is 4, here it is 1. That is 5 is already there. So the remaining value is 9. And see, 9 is nothing but 3 square. So if nz value is 3, that is nx equal to 1, ny is equal to 2 and nz is equal to 3, then we will get the energy E is equal to 14 pi square h square by 2ma square. So then what will be the corresponding wave function? That is, psi will be equal to 2 by a all raised to 3 by 2 sine. What is the nx value? 1. That is pi x by a into sine ny. What is the ny value? That is 2 pi x by a into sine nz. See, nz. What is nz value? 3. That is 3 pi z. Here it is y, not x. Y z by a. So we got the wave function corresponds to this energy. So which one is the answer? See, option D. 2 by a all raised to 3 by 2 sine nx is here 1, here ny is equal to 2 and here nz is equal to 3. Okay, so this is the answer, option D. Here the question is to find out the ratio of energies E1 by E0, where E1 is first excited state energy and E0 is ground state energy. And this is for a 3D rectangular box of side. It's a 3D box and the sides are given. So one of the side Lx equal to L, Ly is equal to L and the Lz is equal to L by 2. Okay, so these are the sides of the box. So we know the energy of a 3D box, that is E equal to nx square by Lx square, that is this is the general formula, plus ny square by Ly square plus nz square by Lz square into pi square h square by 2m. Here in this given question, we have to substitute this Lx value, Ly value and the Lz value. So we will get energy E is equal to nx square by Lx is L square plus ny square, Ly is L square plus nz square by Lz is L by 2 whole square into pi square h square by 2m. That is, we will get energy E is equal to, we can simplify this one, that is we can take this L square term outside. So we will get nx square plus 2ny square plus 4nz square into pi square h square by 2ml square. Okay, so this is the equation to find out the energy of this particular case. And here we know the nx can have values 1, 2, 3, etc. And ny can have values 1, 2, 3, etc. Nz also can have values 1, 2, 3, etc. So first we have to find out the ground state. So for the ground state, what will be the nx, ny, nz value? That will be 1, 1, 1, right? That is the lowest nx, ny and nz value. That will be the corresponding ground state energy. That is nx equal to 1, that is 1 square plus 1 square plus 4 into 1 square into pi square h square by 2ml square. So we got the ground state energy is equal to, that is 1 plus 1 plus 4, that is 6 pi square h square by 2ml square. So we got one of the value, that is we got E0 is equal to this one. Now we have to evaluate E1, that is first excited state. For first excited state, that will be the next higher energy level. There are two combinations are possible. One is nx, ny, nz. If nx equal to 1, ny equal to 2 and nz equal to 1, or nx equal to 2, ny is equal to 1 or nz is equal to 1. So both of this will give first excited state and the same energy, right? Because the nz term corresponds to 4nz square. So we cannot take that one as 2 because it will be higher, very higher energy level. So the next higher energy level will be corresponds to nx equal to 1 and ny equal to 2, or nx equal to 2 or ny is equal to 2. So for both this case, we will get same energy, that is we will get E1 is equal to nx square, that is 1 square plus 2 square plus 4 into 1 square, or the other combination, that is 2 square plus 1 square plus 4 into 1 square. So both this case we will get the same energy, that is 1 plus 4 plus 4, that is 9, right? That is the energy is equal to E1 is equal to 9 pi square h square by 2ml square. The question is to find out their ratio, that is E1 divided by E0. Okay, that is E1 is 9 pi square h square by 2ml square divided by E0 is 6 pi square h square by 2ml square. So we will get the value 9 by 6, that is 3 by 2. That is answer A, right? In this question, a particle of mass m is confined in a 3D box. So this is a 3D box problem. And the potential is given, that is potential is 0 when x, y and z are in between 0 and a. That means the length are Lx equal to, Ly is equal to, Lz equal to a. Okay, the particle is trapped inside this box of length a. And it is infinite, otherwise that is outside the box the potential is infinity and inside the box the potential is 0. That is, it is about a free particle. Okay. And the question is the number of eigenstates of Hamiltonian with energy is. That means there is different states having the same energy 9 pi square h square by 2ma square. That is, this question is about the degeneracy. So first you have to consider the expression for energy for 3D case, that is nx square by Lx square plus ny square by Ly square plus nz square by Lz square into pi square h square by 2m. That is, here in this question Lx and Ly and Lz are A. Therefore, we get energy for this particular case is equal to nx square plus ny square plus nz square into pi square h square by 2m square. So we can take different combination of nx values 1, 2, 3, etc. and ny values 1, 2, 3, etc. and also for nz values 1, 2, 3, etc. Now we can check which of the combination of nx, ny and nz will give this energy 9 pi square h square by 2m square. So first I am taking nx is equal to 1. That is, energy will be equal to 1 square plus ny also I am taking as 1, that is 1 square plus. So the total value should be 9, right? So the remaining time is here, it is 7. 7 is not a perfect square. So any combination of nz is not suitable here. Okay, so this is not a possible combination. Another one, that is, I am taking nx as 1, ny as 2 plus. So the total value should be 9. So it is 4 plus 1, 5. So this will be 4. Okay, 4 is a perfect square, that is 2 square. So one combination is possible, that is nx equal to 1, ny is equal to 2 and nz is equal to 2. See, we can interchange these terms, that is, we can take nx equal to 2, ny is equal to 2 and nz equal to 1. Then also we get the same value 9, and other combination is also possible, that is nx equal to 2, ny is equal to 1 and nz is equal to 2. Again we get the same value 9, right? So for this 3 combination, the energy is 9 pi square h square by 2m square. That means there are 3 states, that is, one is psi nx value is 1, ny value is equal to 2 and the nz value is 2. Okay, and other wave function is, or state is psi nx is 2, ny is 2 and the nz is 1. Okay, and other combination is psi 2, 1, 2. All these 3 states have the same energy 9 pi square h square by 2m square. That means the number of eigenstates of Hamiltonian with energy is 3. That is answer C.